Here I explain direct form FIR realization using one example. Here I take the transfer function h of z is equal to 1 plus 4 into z raised to minus 1 plus 5 into z raised to minus 4 plus 3 into z raised to minus 5. In our example, or our transfer function has only a numerator and there is no denominator. That means the system is FIR. From the definition of transfer function, we know that the transfer function is output by input. Let us take x of z as the input and y of z as the output. Now the transfer function h of z can be written as h of z is equal to y of z by x of z. And now the first equation is replaced by y of z into x of z is equal to 1 plus 4 into z inverse plus 5 into z raised to minus 4 plus 3 into z raised to minus 5. Multiplying both sides by x of z, we can rewrite the above equation as y of z is equal to x of z plus 4 into x of z into z raised to minus 1 plus 5 into x of z into z raised to minus 4 plus 3 into x of z into z raised to minus 5. Keep that equation as equation number 3. Then take z transform on both sides. We got, that means take inverse z transform. Take inverse z transform on both sides. We got y of n is equal to x of n plus 4 into x of n minus 1. That is the z transform of z raised to minus 1 is equal to x of n minus 1 plus 5 into z transform of z raised to minus 4 is equal to x raised to n minus 4 plus 3 into z transform of z raised to minus 5 is 3 into x of n minus 5. That is equation number 4. By analyzing the equation 4, we got, there are three mathematical operations. First one is addition. Second one is there is multiplication. That is the coefficient is multiplied. Coefficients like 4, 1, 4, 5, 3 are multiplied with the shifted sequences. And there is a delay for shifting each sequences. Here I explain how can we draw an FIR in direct form. Our example is y of n is equal to x of n plus 4 into x of minus 1 plus 5 into x of minus 4 plus 3 into x of minus 5. The input is x of n. From this point, I draw a line. And we know that from this equation, it is clear that the first sequence is shifted by 1. That shifting sequence is z raised to minus 1. And the output of that delay network is x of n minus 1. From in this equation, after x of n minus 1, the next sequence is x of n minus 4. 5 into x of n minus 4. That means the first shifted sequences are again shifted by z raised to minus 1. Now we got x of n minus 2. Again we use a delay block z raised to minus 1. From after that shifting we got x of n minus 3. Again we use another delay network, that is z raised to minus 1. Here we got x of n minus 4. After x of n minus 4th sequence, there is one more sequence is there, x of n minus 5. So we want to use another delay in this realization, that is also z raised to minus 1. After that we got x raised to n minus 5. The coefficient of x of n is 1. So I draw a 1 here. I did not mark a 1 here. And this first two sequences and the shifted second sequences are added together. Here the shifted sequence is multiplied by 4. Then after the first shifted sequence, there is the next sequence is x of n minus 4. So we draw x of n minus 4. Here we use another summer, and x of n minus 4 is multiplied by a coefficient 5. Then after the x of n minus 4, the next sequence is x of n minus 5, that is multiplied by a coefficient 3. So we use another summer, that is multiplied by 3. Then after x of n minus 4, 5, we got y of n. This is the direct form realization of an FIR system. This structure is also known as tapped form. In this section, I will explain the transposed version of direct form FIR system. From the same example, that is y of n is equal to x of n plus 4 into x of n minus 1 plus 5 into x of n minus 4 plus 3 into x of n minus 5. We can draw the transposed version. First, the input is x of n. Input is x of n. From that, the next sequence is shifted by 1. So I use a delay here, that is z raised to minus 1. After this delay, the sequence become x of n minus 1. In the example, after the sequence x of n minus 1, the next sequence is x of n minus 4. So we want to shift the first shifted sequence into 3 times, that is z raised to minus 4. That time we got x raised to n minus 2. Again it is shifted by 1, z raised to minus 1. This time we got x raised to minus 3. Again we want to shift one more time, that is z raised to minus 1. Now we got x into n minus 4. After the x into n minus 4, the next sequence is x into n minus 5. So again we want to use another delay block, that is z raised to minus 1. After this shift we got x raised to n minus 5. Now the coefficient of x raised to n minus 5 is 3. So 3, and the coefficient of x of n minus 4 is 5. This one 5. So here I multiplied 5. These two are added together. Then next sequence is x of n, that is multiplied by 1. And this sequence and the first shifted sequence, that is x of n minus 1. The coefficient of x of n minus 1 is 4. Both are added together. And finally, all these sequences are added together and we got y of n. And this structure is known as transposed version of direct form FIR system.